In this video, we will look at the connections between an arithmetic recursive formula and the explicit formula for that sequence. It's a way to make it a little easier to work with a sequence and to find the numbers, and it's going to develop us into our idea of our linear equations, which we'll talk about in another video. So let's start with a sequence. Let's look at this sequence. U sub 0 equals negative 4. U sub n equals u sub n minus 1 plus 3. It is definitely an arithmetic sequence because to find my next term, I'm going to add a number to my previous term. I got that common difference. So to see how this is acting, let's draw a quick graph. As we graph one of these sequences on the coordinate planes, remember we put our n values on the x-axis and our u sub n goes on the y-axis. So for this sequence, we are starting with u sub 0 equals negative 4, so I'll put my dot at negative 4 on the y-axis, because that's where n equals 0. When n equals 1, I'll move up 3. 1, 2, 3. And we'll move up 3 again for the next one. 1, 2, 3. 1, 2, 3, and over for the next one. And 3 more and over takes us to 8. And 3 more will take us over here up into our words. As we see these line up, nice and linear. And this is, again, what we remember with our arithmetic sequence. With the arithmetic sequence, the dots should line up in a line. So, remembering what we did in Algebra 1 with a line, when we're writing to write the equation of a line, we need to know the y-intercept, or the y value when x equals 0. And this is right there at negative 4. So my y-intercept is the point 0, negative 4. And we need to know the slope. The slope is how much do I go up when I go over 1? How much do I go up each time? And that's actually defined in my sequence. Each time I'm going up by 3. So my slope would equal 3. So this would give me the equation using n and u sub n. My u sub n value is going to be my starting value, which is not 3. Let's go back here. My starting value is negative 4. And then each time my n increases by 1, I go up another 3. So I get this equation u sub n equals negative 4 plus 3n. This is what I call my explicit formula. And of course, this one was my recursive formula. This works out really handy in this example, and in fact, this will work in all examples. Your starting value, your u sub 0, is the same as your y-intercept. Now, this is true only if you're starting with a y sub 0. If you are not having your starting value as y sub 0, we cannot call that the y-intercept, because again, that y-intercept is where x equals 0. So we need n, because x is right now my n, so n has to equal 0, so we have to have a starting value at y0. If we don't have a u sub 0, we're going to have to do something to find that. Our common difference is the same thing as the slope. Because either way, where we're talking about the common difference, this is how I'm changing each time. And that's illegible, so let's rewrite that. That's how I'm going to change each time. And that's really what the slope is. The slope is the rate of change. So we will find this in general for any arithmetic sequence. We can write this explicit formula. So let's put this in more general terms. In general, if you have an arithmetic sequence where your u sub 0 equals a, and your u sub n equals u sub n minus 1 plus b, we're adding b each time, your explicit formula is u sub n equals a, your starting value, plus b, your difference, times n. Now, quick note, this double-headed arrow here, we use this to mean as equivalent. And basically what it means is if I have something written like this, I can change it over to this explicit form. And if I have it in the explicit formula, I can switch it over this way back to the recursive formula. That's why we have the double-headed arrow on that. So let's look at a few examples using this. If we're given the formula u sub 0 equals 200, u sub n equals u sub n minus 1 minus 3.7, to write the explicit formula, we start with our starting value, 200. So u sub n, we're going to start at 200. And then we look at this change, negative 3.7. We're subtracting each time, so we'll subtract 3.7 times n. Now say I want to be cruel to you and say, find u sub 300. We could use our recursive formula, and we could make our table and go up to the 300th term, or we could type it in the calculator and wait for it to find that 300th term for us. Or we can use the explicit formula. If I want u sub 300, I just take 200 minus 3.7 times 300. And that gives me my u sub 300 is a negative 910, which is a much easier way to find that. But where this becomes even nicer is what if I went the other way around and I said u sub n equals negative 269.9, find n. In this case, you have to write out the table and keep looking to find that elusive negative 269.9 and find out where that shows up on the table. But again, with our explicit formula, we know u sub n, so I can type that in, negative 269.9 equals 200 plus, not plus, undo, minus, let's give myself a little room here, 3.7n, and I can solve this problem for n. So I'll subtract my 200, get the n all by itself. I get negative 469.9 equals negative 3.7n. I'll divide by negative 3.7, negative 3.7, and I end up with n equals 127. So there's my value. This negative 269.9 is u sub 127.